Hello everyone, and welcome back to MIS 5000, Special Topics in MIS. In today's module, we're going to talk about functions, see some examples of functions that you have already used, delve deeper into the different components of a function, and then use some of our previous flowcharts and turn those into functions in Python. The Module 9 learning objectives are as follows. After this module, you should be able to write a function in Python, define and use the terms define, call, pass, argument, parameter, and return, define and implement local and global scope in Python code, and define local and global variables. Here is a reminder of the 4 processes we've looked at in programming logic from the textbook. I bring this up to indicate to you that each of these items could actually be implemented inside of a function. So when we're talking about functions, we're really talking about creating a way of encapsulating code into a structure that we can then call and reuse over and over again in our code. So any of these pieces of programming logic can be included in a function. So what is a function? A function in Python takes an action when executed. There's some terminology here that you need to be able to use. So functions are passed arguments in parentheses. We'll see an example of that. So for example, when we use the print function and we put in quotes what we want printed to the screen, we are passing that string as an argument. Some additional terminology: functions are called when they are executed. So whenever we type print and then run our program, that print function is being called during that run. We have also used the string, float, and integer casting functions. So we've used these functions to indicate what data type we want for a variable or a value. Use the str function to treat the variable or value as a string, int to treat it as an integer, and float to treat it as a float. And you've also seen that we can nest functions inside one another. For example, we have used int around the input function in order to cast the user's input as an integer for further use. We have also used the length function. So recall that the length function takes a string value or variable as an argument and determines the length of that string. So for example, we could print the length of the string meet my 11 cats. We would have to include all of the characters in that string. So 1, 2, 3, 4, count the space, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 with the period. And I think there's actually an extra space here, which would make that 17. So length of 17 on that string. We could say that the return of this function is the length of that string. So some functions do have returns, others do not, and those have what we call the none return type. We have used predefined functions. We can also define our own functions using this method of function definition. We start with the keyword def to define the function. We then type the name of the function, which can have an underscore if we want further words in the function, followed by parentheses. Inside the parentheses, we might put any of the parameters that that function might take. So for example, if we were defining the print function, we would need to include a parameter for the string that is passed once it is called. This particular function, we have define hello. We then have a colon, and this function, when it is called, so if we were to just type hello below this with the parentheses, it would print howdy, howdy, and hello there to the screen. Note that when the function is defined, it is not invoked. So it is only when the function is actually called later without this definition keyword that it goes into effect. Here's an example of a function with a parameter. So we have the same function hello, but this time we have included a variable inside the parentheses called name. When this function is called, it will expect the user to provide a string inside of the parentheses so that when it is called, it will print hello followed by the person's name to the screen. Some functions take multiple parameters, some take no parameters. Functions may also have return values. So in the case of that length function, the return value is the length of the string. When a function has a return, we simply use the keyword return at the bottom and then provide what is returned. So this could actually be a single variable that has a value. It could be a mathematical expression, any number of things that when evaluated, it gets returned when this function is called. Another good example of a function with a return is that input function. So the input function actually takes in the parameter of the text that you want to display to the user when it is called. It then returns whatever the user types on their keyboard before they hit enter. And we are said to catch the return by putting a variable and an equal sign in front of that input statement. In the case of this hello function, we have hello takes name as a parameter. We set greeting when it is called equal to hello plus the name that is passed, and then we return the greeting. So we return the string hello. And functions that do not have a return actually have a return that is the none value. So this is a value that represents no value. This is not the same as a value of the integer 0 or false. You can think, if you know Java, that this is similar to the null value. It has a special data type called the none type data type. When there's no return statement in a function, there's a default return of none. So if we were to call a function that has a none return and print it to the screen, we would see that none type data type. And we can test this by printing a function with no return value. In terms of terminology, there is a difference between an argument and a parameter, although many people use these terms interchangeably. Parameters are included in the function definition as an indication of possible arguments that can be passed into the function when called. For example, the hello function has one parameter, and since it has not yet been called in the code, we do not have any arguments. So name serves as a parameter. Say I pass the string Bob into the hello function. When I call it, Bob then becomes the argument that is passed. When we talk about functions, it is a great time to introduce the concept of scope. So in particular, the difference between local and global scope in a program. So parameters and variables assigned in a called function are said to exist in that function's local scope. So say you call the print function and you pass in a string. Once that function is called, whatever goes on inside of that print function exists within that local scope, and it terminates after that function completes what it needs to do. Variables assigned outside all functions are said to exist in the global scope. So if we, for example, assign x a value without placing it in a function, it exists in the global scope of that program. The difference between local and global scope is important because it determines how you can name your variables as well as how different values interact with one another within the program. So a variable that exists in a local scope is called a local variable, and a variable that exists in the global scope is called a global variable. And a variable has to be one or the other. It cannot be both local and global. Code in the global scope cannot use any local variables. So in other words, if you have a function call and there is a variable within that function call, the global scope does not have access to that local variable. However, the local scope can access global variables as they exist throughout the program. Code in a function's local scope cannot use variables in any other local scope. So for example, if you call the print function twice in the same program, those variables are not able to mix. You can use the same name for different variables if they are in different scopes. So if you have two separate functions, for example, that take in a person's name, in that definition, in that call, you can use that same name variable twice. So there can be a local variable named spam and a global variable also named spam. At this point, we're going to take a look at writing some functions. So the first thing we're going to do is create a mini calculator for ourselves. So we're going to define 4 functions and then see the call of each of these functions in Python. So we want to create an add, subtract, multiply, and divide function. Each function will take in parameters a and b. Remember, the local and global scope rules tell us that we can have a and b in multiple separate local scopes. And each one will return either a plus b, a minus b, a times b, or a divided by b. So let's go ahead and take a look at our calculator in Python. We have 4 functions we want to create. So add, subtract, multiply, and divide for our calculator. We'll start with our function definition using the keyword def, followed by the name of the function add. In this case, our add function has 2 parameters, a and b. So I'm simply going to type a and b inside the parentheses, separated with a comma. If you've used other programming languages in Python, we do not have to list the variable type. So that will be performed on the fly. We follow this with a colon, and then just like everything else in Python, whatever we want to be inside this function, we need tabbed out at one level at least. This function is to take in a and b, and it will have a return. It will have a return of the sum of the two. Now we can do this in multiple ways. We can declare a new variable, set it equal to a plus b, and return that variable like so. So for example, z equals a plus b, return z. Let's go ahead and test that, and then we can simplify it. So at this point, you'll notice if I save and run that nothing happens. So this is because we've only defined the function, we have not yet called it. If I want to call this function, I simply write it in the code, and I can put in integers, for example, 1 and 2. Of course, if I run it at this point, I still won't get anything because I haven't printed anything to the console. This is to demonstrate to you that you can, of course, nest functions. So for example, I can print add 1, 2. We should get 3 printed to the console, and we do. We can actually use that mathematical operation directly inside the return and not have to create a new variable. So for example, we can just say return a plus b. Let's go ahead and test that. See, we still get 3. Take a minute and see if you can implement the rest of these calculator functions. You can pause and come back, or if you're confident, you can just plow on through. I'm going to go ahead and add the rest of these functions here. So we have def sub a b, which will return a minus b. Let's define mult as takes in a and b as parameters and returns a times b. And finally, our division, a b, which will return a over b. So again, if I run this, you'll see that nothing happens at this point because I've only defined the functions, I have not yet called them. If I want more space, this editor actually allows me to minimize the details of each function. This can be useful if you have a function with a lot of code in it. Just kind of get it out of your way while you're working in the rest of the program. So let's go ahead and do some testing. So we'll set x equal to add 1, 2, y equal to add 2, 3, z equal to mult x, y, and see what happens. Of course, nothing happened because I didn't print the result to the screen. Let's go ahead and print z. And I want you to guess at this point whether or not I will get an error, because z may either be acting right now as a string or an integer. So what do you think? I go ahead and run it, and actually it is being treated right now as a string, so I don't get an error, and I get 15 printed to the screen. To illustrate scope, you can see some of the rules in effect here that I could use A and B in different local scopes. So I used A and B actually 4 times in 4 separate functions, and this A is not the same as this A. I can also, because it is a different scope, use A out here. So for example, A equals add 2, 4, and I can print A. I get 6. You'll also notice, I'd like to show you that we can nest functions multiple times and that things evaluate from the inside to the outside. So for example, I can do add and then call the function twice within the add function. So for example, add 1, 2, add 3, 4. So what will end up happening is this will evaluate to 3, this will evaluate to 7, and then this entire result will evaluate to 10. I can actually nest that inside a print function like so. And you see I get the result of 10. So this is a brief example to show you how to define very simple functions, to talk a little bit about scope and see how you can nest functions and how they evaluate. I will post this example to Blackboard. Now let's go ahead and take a look at some of the previous flowcharts and code that we've already written and see if we can turn them into functions. So I want to walk through a couple of these just to show you when something is a good candidate for being part of a function, and maybe when it's best to just leave that within the global scope. So let's take a look at this first example. Remember, we had this application that simply prompted the user for a number, multiplied that number by 2, and shared the result. So when I'm looking at this, what I'm thinking is I'm going to prompt the user outside of a function. I will pass their number into a function that multiplies by 2 and then returns that number. Let's take a look at this example in Visual Studio Code. Okay, so I have the definition at the top. Let's go ahead and define our function. I'm just going to call it mult by 2. And it is going to take in a number. I'll add my colon, and basically what I want it to do is multiply the number that is taken in by 2 and return the result. So I can either make a new variable and return that variable as number times 2, or I can simply say return number times 2. Then I can go ahead and finish out the rest of the original program. So we do the following, that we take in number. Now remember, I can use number here the same way because it's not in the same scope as that function. So number equals, cast this as an integer, input, enter a number. We will then call the mult by 2 function on that number argument. We will then call that mult by 2 function and pass in our number as an argument and return the result. So let's go ahead and have our result be equal to mult by 2 and pass in number. And then print our number, remember to cast as a string, times 2 plus cast the result as well, although I believe that is a string. And here we go. So run it, enter a number, enter 3. And it says 3 times 2 is 6. Forgot the equal sign, so let me just add that and run it again. Enter a number. 10 times 2 equals 20. So what you can see is that I chose the process of multiplying the number by 2 as a candidate for encapsulating in a function, and that worked out fairly well. In this particular example, it is a very simple function, and we could probably just write out the entire program. But there are cases where maybe we want to use that process over and over again, and it makes sense for us to close it in a function. Let's take a look at one more example. So recall the compound interest example where we asked the user for their principal, rate, the number of times the interest was applied, the number of time periods that it would be compounded over. We calculated the amount based on their principal and then returned to them the final amount. So we're going to encapsulate some of this in a function. I'm going to go ahead and comment out this piece of the code to show you that we can keep that original function while we write this new one. So I think what I'd like to do is again enclose the calculation in a function so that we don't have to see that in the main code. So let's define this as compound interest. And here we're going to pass in several different parameters. So we'll have the principal, and I'm going to use these shortened names. So P, R, N, and T. And inside the function, we are going to return the principal times 1 plus the rate over the number to the number over the time power. So it's going to look like this. Actually, let me go ahead and use a separate variable in this case so you can see what that looks like. That amount equals P times 1 plus R over N to the, remember the exponent is the double multiplication symbol, the number over the time. We then have to make sure we return the amount. We're going to take a similar approach with this, and so we've put this process into a function, we're going to do the rest in the main code down here. So let's first again get the principal like we did before, and we will cast these as floats. So we will first ask them to enter the principal, then the rate, similar, cast it as a float, then the number of times the interest is applied, number of time periods, and then after we collect all of those inputs, we can then call the compound interest function and return its result. So we can use a separate variable to catch its return, or we can simply cast it when we print it to the screen. Let's go ahead and use a separate variable. I'm going to call this result, although we could use amount again because it is a separate scope. That will be set equal to compound interest, and we'll pass in all of the variables that we just assigned. So principal, rate, number, and time. And finally print the final amount is plus the result. Let's go ahead and run this, and it will of course ask us for the principal. I'll say 12,000, a rate of 0.025. Number of times interest is applied, we'll say 4, and number of time periods, we'll say 12 for months, and we can see we got a little bit of interest there. Now for the purposes of this course, since we are aiming at writing quick scripts that allow us to accomplish simple tasks and automate them, we're not going to focus so much on objects, although Python is an object-oriented programming language and functions are a major part of object-oriented programming. We are going to limit ourselves to simply defining functions on their own that will allow us to simplify things in our code. I will also post this to Blackboard. If you have any questions about any of these examples or functions in general, please let me know.